Hey everybody, and welcome to the pilot episode of League and Learn. I got the idea based off Lunch and Learns, where you're learning about something in an informal setting while doing something that you enjoy. And my goal is to teach people about topics that were really important when I was first starting off my software development career. Essentially, I want to give people the advice and the explanations that I wish I had at that time, instead of having to fish for the information myself. So for this episode, I'm going to be explaining the clean coding principles, what they are, and why they're useful. So what is clean code? Basically, clean code is code that is easy to read and easy to change. That definition doesn't really help too much. It's one of those I can't define it, but I know it when I see it kind of things. But it gives you an idea of what the goal is. The whole point is to make collaboration easier and to make it easier to change things in the future. Because no one has perfect information about the future, so you never know what changes you might require to your application. I had a lot of trouble with the idea of clean code when I was first starting out because I wasn't really able to see the benefits to it. So people would just say, this code isn't clean, clean it up, but I wouldn't see why I was doing that. So my goal is to help illustrate why it's a good idea to follow these principles. And these are just guidelines, so it's not going to tell you how to write a perfect application, but it is going to tell you what you should avoid and what you should strive for to make the development process go more smoothly. The first principle I'd like to talk about is called Keep It Simple, Stupid, also abbreviated as KISS. This principle is saying that each component of your code should only be as complicated as it has to be. This is something that new people break all the time when you see giant functions with a ton of lines of code and doing pretty much everything that they need to in a program, trying to fit everything into a controller or something like that. This means that when you have to change something, and change is inevitable, you will have to crawl through this huge function trying to track down every single instance of whatever it is you need to change, even for these little tiny adjustments. To fight this, you can use what is called the principle of single responsibility. Each component should only be concerned about one thing. You should only ever have one reason to change a component. I'm going to use an example from React here because I love to pick on React, and it's something that I'm guilty of myself. If you have a component that is trying to display user information, that component shouldn't also be in charge of fetching the information. Rendering and fetching should be done as two separate concerns. So you can have a service that fetches the information and then passes it as props to the component that renders it. And what's the benefit of doing it like this? Well, if you're changing how the information is fetched, then you only have to change that service. You don't have to change everything. It's the same thing if you're trying to change how it's rendered. If you want to change that, all you have to do is change the rendering component instead of changing this massive class that would have all of the concerns there. Especially for when you're working in a team setting, making it so that changes affect little small components or services or classes makes collaboration so much easier. The next principle is called Don't Repeat Yourself, abbreviated as DRY. It's closely related to the KISS principle because it's all about keeping code modular and simple. Each piece of code should be the single source of representation of a functionality. An example of this would be like authorization in a web application. So let's say that you have a page that is protected. You only want administrator roles to be able to access that page. Well, you can go in, you can check if the active user is an administrator, blah, 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 you know how to do it. But if you then have another page that you want to protect, and it's also only accessible by administrators, instead of rewriting that same code, you could extract all of that to a separate function and use that function in multiple places. You can also generalize these extracted functions. So let's continue with this example. If you have another page that's accessible to administrators, but also to another role, managers, you can pass in the user and then this list of accessible roles, like managers and administrators. So if the user is a manager or an administrator, they're allowed to see that page. I think a good rule of thumb here is that if you're repeating yourself more than once, you should extract it out to a generalized function. Repeating yourself once isn't really a big deal, and it might be more awkward to generalize the function than it would be to just rewrite most of the code that you're doing. But once it gets past that point, then you're kind of just wasting time and making things more difficult for yourself. Now, the big exception to the DRY principle is when it comes to testing. Unit tests should each be their own encapsulated piece of logic, and you should be able to look at a unit test by itself and figure out what it's testing, what it's doing, and what the expected outcome is. You don't want to be looking at it and seeing all these external function calls because that makes things more complicated. Repeating yourself in unit tests is not always a bad thing. Next, we have the principle called "you aren't going to need it," abbreviated as YAGNI because people love their stupid little abbreviations. This is saying that you should only add functionality to software when you actually need it. Don't add something because you think you might need it someday in the future or whenever. To break up the monotony of these examples I've been giving, let's say that you're loading in a game of League of Legends as Ornn, and you see an enemy team with 5 AP on them. You're not going to build a Thornmail, even though Thornmail's a really good item, because why would you need it against 5 AP? Now, if something changes and their Nico decides to go AD, or they have some weird AD Karthus unicorn on their team, yeah, you might need to build a Thornmail. But don't go in thinking, I'm going to build this because it's a good item. Think about what you actually need at the time. Next, we have the favoring of composition over inheritance, which is not an acronym. Thank God we're done with those. This is basically saying that you should prefer to make your models based on what something is doing versus what it is. Now, this is a topic that I could devote an entire video to, which I might do in the future. But for now, you just have to understand that composing something of multiple classes or objects or what have you, instead of inheriting from a parent, makes it a lot easier to change things in the future. It makes it a lot easier to test these classes that you're making, and it also makes it resistant to breaking changes if something happens to the parent class. It also requires less planning. If you're using a model of inheritance, you kind of need to know what all of the objects that you're going to be using in the future are right from the beginning, as opposed to with composition, where you can make changes more easily without breaking everything. Probably the most important principle to me that comes with clean coding is readability. Your code needs to be readable not just by computers and compilers, but by other people. Unless it's a side project, you're generally going to be working with other people, and you need to be able to read their code just as much as they need to be able to read yours, because you're never really going to be working on, like, okay, this part of the application is mine, that part is yours, that part is his. That doesn't work. That is not effective teamwork. So instead of writing clever code that saves a line here or there or makes you look really smart, write something that's readable so other people can go in and make changes to it if they have to. Because even if you're writing something that's perfect for the time, something might come along that changes what you need it to do. And there are other things that you can do here too, like avoiding so-called magic numbers and using well-named constants instead, and making sure that your variables have descriptive names. Like if I come across the variable user has write access, it's not really difficult for me to figure out what that's doing. The last thing to talk about is consistency. Whatever you're doing, make sure you're consistent with it. Be consistent with your naming principles, what kind of loops you're using. Like, don't switch to a for each loop if you've been using for loops the entire time, unless you have a good reason to. And if you have a good reason, make sure you comment it so people understand why you're doing it differently here. It's, once again, all about making sure that your code is easy to read and easy to change. I hope you enjoyed this pilot episode of League and Learn. If you'd like to see more content like this, you can subscribe to my YouTube channel, or you can click on the link to my Twitch stream.